Hi guys, I just wanted to show you what I've done last night. I understand it's Friday night and people should be in the pub, but unfortunately I'm trying to get things done before I leave next week because I'll be away for most of next week. So what I did is, and you can see it in this picture, so I did a bunch of experiments using different materials and the transthoracic probe. I used a different machine than the one we used last time for no good reason, but just because I needed that machine for something else and I had it in my office. So you'll see that the screen layout is a little bit different. So the first thing I did, I just put the probe in water, as you can see here, and this is what I saw. So this is just the bottom of the container, and this is just water. And you can see that there's little sparkles within the water that are they're bubbles. And what I also noticed is that, which is not surprising, without really doing much, but just waiting. Soon after I put the water in the box, there were more bubbles, and then the bubbles got better. So what I did is, the first thing I did is I took the famous sort of experimental phantom that we have in PLA, which is here, and this is the scan of the phantom in PLA through the hole from the top. So you can clearly see here is the hole at the top. You see the triangle, you see the base here. It's in water, there's still some water bubbles. There's here some artifacts from just the material itself, but you can see this triangle quite well. Then the next thing I did, I tried to look through the wall, and you can see here I was actually quite surprised to see how nice through the actual sort of thin dome, through the actual wall, you can see there at the top, you can see this triangle and the base quite well. Then what I did, I tried to scan around, and here it's from the side of the dome, and again through the dome I can see inside, and I can see this triangle quite well at the bottom here. Then what I did, I moved to the other side, and as you get the corner between this semicircle and this straight, you sort of lose the resolution inside, and I think it's due to this flat surface, because you're gonna see in a minute, if you take this model and you flip it upside down, and now you look through the bottom of the dome, you just don't see anything. So a flat surface, it is reflecting all of the ultrasound you can't see through. So that's what I learned, which is actually not surprising. What I did next here, I took the other model with NinjaFlex, and here is the model with NinjaFlex through the hole. And if you want to compare it to the PLA model, this is PLA, and this is NinjaFlex. So really not big difference, and if anything, I'd say that the PLA is better. Then what I did the same thing. So looking through this, the dome, you can kind of see the triangle here at the bottom, but it's not very clear. And then I'm looking through the side, pretty much the same as the PLA. And here is looking from the bottom, through the bottom. You basically flipped it and you don't see much. So this is NinjaFlex in water. So my conclusion is NinjaFlex is definitely not more echogenic than PLA, and it's more expensive. So I don't think we get any advantage by printing in NinjaFlex for now, at least that I can see. So I think we should stick to PLA. The next thing I did is I tried to scan the object in PLA, I think it was, that was encased in gel. And this is object through the gel. And I just scanned around and looked at sort of different sides, and pretty much, I mean, everywhere you look, you can't really see through the plastic. So the plastic or the PLA, it's actually too thick, so there's no really much you can see. Here you can see. There's not much you can see here. This was the experiment. So encasing the object in gel doesn't make it more echogenic or more eco-transparent. Then the next thing I did, I took the gel alone, so the gelatin alone. And this is gelatin number 1, that is the most transparent one, the one that didn't have metamucil, or if it had very little. And here you can see the surface. This is the gel itself, by itself. I just put the probe on top of it, and this is the bottom, this is the top of the gel, and I think this is a reverberation artifact, this is a reverberation artifact, just because this is the surface of the gel. So it looks very eco-transparent. Now, what I did, I put the gel in water, and here is what you see. So the gel, or the ballistic gel, basically looks like it has the same ecogenicity of the water, and all you see around the gel, this layer of white stuff of this block of gel, it's just due to micro bubbles that are on the surface of the gel. I actually kind of liked it quite. It's very nice. So, and you can see here at the bottom of this box, that's plastic, and that's the gel with the micro bubbles. So this is confirming, I think, Azad's idea that if you add graphite or something in the layer between different blocks of gel, you may be able to actually display something. And I think this is a good example. There's no graphite, but this is actually air bubbles around it, and you can see inside it's just as ecogenic as the water. Then the next thing I did, I took the second piece of gel with more metamucil. And this is actually becoming quite interesting, because this is the same piece basically submerged in water. And you can see that this piece is definitely less ecogenic than water, or more ecogenic than water, or less eco-transparent than water. So you can clearly see the difference between water and this metamucil gel, where you cannot really see it. Here I go again to the first piece of gel, where there's gel number 1 in water. That's metamucil. This is just another picture, and if you look at it, it really looks, makes me kind of happy, because it's sort of confirming the idea I had. It kind of looks like myocardium. It's very similar to myocardium. Now what I did, I just stacked the 2 pieces of gel, one on top of the other. So this is oh no, sorry. What did I do? Oh, here I look at the gel number 2 alone, which is here. If the gel is next to the probe, you can't really see the difference. From here to the gel where I was looking at the gel alone before. This is the gel number 1. It's a more zoomed image. And this is gel number 2. So there's not much of a difference. If you get far away from the probe in water, you can see the difference. Here what I did is I put the gel number 1, which is the most transparent one, on top of gel number 2. And here you can see gel number 1 is here, gel number 2 is here. And here you have the more eco-dense gel, less eco-transparent gel, which is gel number 2 with more metamucil at the bottom. And you can see the difference between this and this. And probably if you add more metamucil, or if you make it the same as what you did last time you scanned with Azad, you probably get something that's very similar to sort of muscle. And this is my conclusion from this picture, is that gel number 1 is actually behaving pretty much like water. And this is, I just reversed it. So this is gel number 2, that's the more eco-dense, and this is gel number 1, that's the more eco-transparent here at the bottom. You can't really see, you may kind of imagine a little bit of grainy, but not much. And then as the last experiment, what I did is I put the gel at the back of the PLA at the bottom, while after I put it in water. And you can see that this is the same that I was trying to do as this other picture here, where actually initially no, wait, here. So here is water, and now you look, gel and water. So with gel, it gives you a little bit of advantage, and it looks like, and you get probably better coupling, and you can see through a little bit more, even if the surface is flat. So there may be a little advantage by encasing the PLA in gel, but I'm not sure the advantage is significant to justify the pain of encasing the PLA in gel. Now, the other thing that I did that I wanted to show you is I went for dinner and I left, so this is me scanning the PLA from the back. This picture corresponds to this picture here. This one and this one. That's basically what happened. So I was looking like this, and this is what I saw on the screen. Now, the other thing that I did is we were wondering what happened to the gel if you put it in water. And this is what happened. So I left the gel in water for over an hour because I went for dinner, and this is what happens when I came back. This is the gel as I took it out of the water. The water was pretty much like room temperature. So no, well, maybe a little bit colder than room temperature, but then it sort of settled to room temperature. And I mean, from what it looks, well, from what you can see here, the gel is pretty much the same as the gel is pretty much the same as we had it from the beginning. So I am tempted to think that if we print a model of the heart in PLA, or like a simple model of the heart in PLA, it's possibly scannable in water. And if we make a double wall of in the left ventricle, we can probably have a look and see how the appearance is on ultrasound. So, and the alternative is Metamucil gel. So if you add Metamucil or whatever you did last time, which unfortunately I haven't seen, it gives a texture to the gel that it looks very similar to muscle or heart muscle. So, which is telling me that if the PLA scannable heart is not an option or it doesn't work, then we can think of a mold or like a cast of printed PLA heart in some sort of gel that can be then submerged in water, or can be, well, no, it should be submerged in water or encased in more gel, which is something that I don't know how you're gonna do it, but you can probably pour gel on gel and that will make it more stable. I mean, it's better than water, because you can see here the drops of water on my desk, and it's messy. Like with the water, it's messy. It's easy because it's water, but it's definitely messy. The gel is a much better option, although the gel is not durable, which I understand, but we can probably look potentially into adding preservatives and cover with the layer. So this is my experiment that I did yesterday. I wanted to share with all of you. I also took pictures of the probe and I'll send it to you in a separate email. I'm just about to upload this video onto YouTube,